Have we just spotted an alien ship? That was the question rattling the minds of every astronomer earlier this year when a new traveler appeared in our solar system. It was fast, it was headed our way, and it was undeniably interstellar. Only the third object we've ever confirmed to have originated from outside of our own solar system. The answer to the alien ship question was clear. Observations from the world's most powerful telescopes quickly revealed the truth. It wasn't a spaceship, it was a comet. Although it might not be ET making first contact, 3I Atlas, as only the third documented interstellar visitor, still has a mountain of secrets to unlock. So what makes this specific comet so special, and what exactly can we learn from it? Interstellar objects, which so far all seem to be comets, are the only physical evidence we've ever gotten that originated outside of our own solar system. Think of it as a silent messenger from deep space, delivering a cosmic letter right to our front door. The moment astronomers discovered 3I Atlas back in July, it was clear that this wasn't a normal comet. For starters, it seemed to be emitting its own light, a truly bizarre finding for an object that was, at that time, still so far away from the sun. Comets are normally extremely dark. Astronomers really struggle to see them at all. It's only as they get closer to the sun that solar radiation causes volatile compounds and ices on their surface to start to melt. These compounds are then highly reflective. The whole melting process creates at first a kind of a hazy developing proto-tail called a coma. This eventually grows into that spectacular streaking tail that we all recognize in the night sky. So for 3I Atlas to appear bright before the sun was even involved, that's what completely redefined the mystery. To put this into perspective, Jupiter is 5 astronomical units or 5 Earth-Sun distances away from the sun itself. Most comets have to travel much closer than that for the sun's radiation to get intense enough to start the whole melting and tail creation process. But what did 3I Atlas do? It formed a coma while it was still outside the orbit of Jupiter, at a far greater distance than was considered normal. This strange behavior, glowing that far out from the sun, was abnormal enough to result in some serious theorizing early on that it might in fact be an alien spacecraft. Because what else that small and moving that quickly would be generating its own light so far from our star? This rare object could help us learn an incredible amount about the conditions and makeup of solar systems beyond our own. It's like a sample straight from another neighborhood of the Milky Way. So the mystery was solved. It wasn't an alien spaceship, unfortunately, but it was undeniably a comet. However, subsequent closer observations revealed something even more mind-boggling about its composition. It showed a clear, spectacular tail, but the analysis suggested this wasn't just a standard water ice. It was likely incredibly rich in carbon dioxide. I know what you're thinking. Why is this a massive discovery? Well, that's because carbon dioxide ice, which you know as dry ice, doesn't melt. It turns directly into gas, and it does so ridiculously easily. This would explain the entire mystery. It's basically a giant cosmic chunk of easily melted dry ice, which started outgassing and shining while it was still frozen solid in the cold darkness far from the sun's warmth. But the most significant part of the story begins with the most powerful eyes in space, the James Webb Space Telescope. It ultimately revealed the comet was unique for reasons that went far beyond its interstellar origins. The powerful space telescope trained its cutting-edge infrared vision, specifically its near-infrared spectrograph instrument, or NIRSPEC, on this cosmic traveler on August 6, 2025. The James Webb, of course, wasn't working alone. It was following in the giant footsteps of the Hubble Space Telescope and the Sphere-X Observatory, both of which had already begun probing the visitor. The entire astronomical community had their biggest tools locked onto this comet for one monumental reason. This wasn't just about taking pretty pictures. The mission was to drill down into the very essence of 3I Atlas, its size, its physical properties, and most critically, its chemical makeup. Because studying a comet like this, one born in a star system billions of years ago and light years away, is like getting a core sample of an alien planet factory. So make sure you hit that like button and subscribe. It's far cheaper than building your own telescope. Astronomers explained that by analyzing the comet's recipe and comparing it to our own solar system's 4.6 billion-year-old construction materials, our own comets, asteroids, and planets, they could finally answer a question that has haunted us since we first looked up at night. How different are the building blocks of life out there compared to what we have right here at home? And when the James Webb data finally came back, the results were absolutely wild. We know the mechanics. When a comet gets sun-baked, the ices on its surface sublimate, or they skip the liquid phase and they go straight to gas. This outgassing is what forms the comet's fuzzy atmosphere or its coma. Pretty simple physics, right? Well, Comet 3I Atlas is playing by those rules. The James Webb looked into its coma and confirmed the usual volatile ingredients: water, carbon monoxide, and the gases that make up its stench, like carbonyl sulfide. But here's where the data took a shocking turn that nobody saw coming. When scientists checked the numbers, they didn't just find carbon dioxide, they found a shockingly high proportion of it. The ratio of carbon dioxide to water in 3I Atlas is the highest ever documented. This isn't a small statistical difference. This unprecedented abundance of CO2 means one thing. Whatever part of the solar system this comet formed in was radically different and probably much colder than we currently imagine. So what does a CO2-packed comet tell us? Astronomers have three big ideas about the mysterious birth of 3I Atlas. The simplest answer is that this comet's icy core, its heart, is simply rich in carbon dioxide. It formed in a different star system where CO2 was more abundant than water, maybe because its parent star was extremely bright and blasted its ices with high levels of radiation. Alternatively, 3I Atlas could have formed precisely at a location called the carbon dioxide ice line. This is the specific supercold boundary around its infant star where CO2 changes from a gas and freezes solid. Being born right there would naturally load it up with huge amounts of carbon dioxide relative to everything else. Finally, there's a heating issue. The low amount of water we're seeing might mean the comet has a kind of heat-resistant armor. Something could be blocking the sun's heat from penetrating its icy core, which means the lower temperature CO2 and the CO are escaping first, while tons of water ice is still locked deep inside, unable to turn into a gas. And this isn't the only crazy thing we've learned about 3I Atlas. All these chemical clues are building on the already mind-blowing discovery that this interstellar comet could be around 7 billion years old. That makes it the oldest comet ever seen, possibly 3 billion years older than our entire solar system. How did they figure that out? By tracking its dramatic path. The researchers who first studied it realized that its steep trajectory through our solar system meant that it didn't come from our neighborhood at all. It came from the thick disk of the Milky Way, a part of our galaxy that's way more ancient than the younger region where our sun was born. With all of these discoveries coming up all of a sudden, the skies are putting on a show we may never see again in our lifetime. But one thing is absolutely certain, the research doesn't stop here. The study of 3I Atlas will continue, and we're going to watch it closely. The James Webb Space Telescope will be heavily involved in the unraveling of this mystery, until the comet races back into interstellar space with considerably fewer secrets than it carried in.